Hello students, welcome to Soras's classes. In this video, I will be solving the following question from ISS 2017 paper 3. Now here, using standard notation, we have to briefly explain the instrumental variable technique for estimating the coefficients in the linear regression model, and then we have to state the situation when this technique is applicable. Now, this instrumental variable technique, this is used to control, for confounding and measurement error in observational studies, for confounding and measurement error in observational studies. So what they do is that they allow for the possibility of making causal inferences with observational data. So they allow for the possibility of causal inferences with observational data. Now let us consider a linear regression model. A linear regression model as yi is equals to beta naught plus beta 1 into x1i plus beta 2 into x2i plus so on till plus beta k into xki plus ui, where this I, it goes from 1 to n, where n is the number of observations, that is I is equals to 1, 2, so on. Now this yi here, this yi, it is the outcome of ith individual. So it is the outcome of ith individual. This xmi, where m goes from 1 to k, this xmi is the mth explanatory variable. It is the mth explanatory variable for ith individual. So yi is the ith outcome, xmi is the mth explanatory variable for ith individual. Now bm, it is the parameter associated with the mth explanatory variable. It is the parameter associated with the mth explanatory variable. So it is the parameter associated with the mth explanatory variable, and this ui, it is the error term or random error term corresponding to the ith individual. So ui, it is the error term. Now suppose z denotes a indicator variable, so it is an indicator variable in this regression model, such that this z is equals to 1 when the treatment is received and z is equals to 0 otherwise, or when the control or placebo is received. So z is equals to 1 when the treatment is received, and z is equals to 0 otherwise, or when the control or placebo is received. Now let x1 be the treatment, So here this z, it is referred to as the instrumental variable, because it satisfies the following condition. The first one is z has a casual effect on x. Z has casual, so it has casual effect on z, So our z has a casual effect on x. It is number 1. Next is z affect the outcome of variable y only through x. So it has a casual effect of x on x, and it affects the outcome of variable y only through x. And number 3, that there is no confounding for the effect of z on y, that there is no confounding for the effect of z on y. So the two criteria which this instrument variable follows is that number 1, it causes variation in the treatment variable, and it does not have direct effect on the outcome variable, that is, it only affects it indirectly through the treatment variable. So if x1 is the treatment variable, then the z will have causal effect on x1. So z will have casual effect on x1, and z will affect the outcome of y only through x1, and that there is no confounding for the effect of z on y, that is, there is no direct effect of z on y. It is only through the treatment variable, which in this case is x1. And these are also the situation when it is applicable, that is, when the instrumental variable will have a casual effect on the treatment variable, and it will have indirect effect on the outcome, that is, only through that treatment variable. In these situations only this technique would be applicable.